Let's do a collision example from chapter 10. This is problem 85. It's dealing with boxcars colliding. So we have two cars, two train cars traveling together at 2.5 meters per second, hit and couple to a stationary car of the same mass. What is the speed of the three cars? And what fraction of the initial kinetic energy is converted into thermal energy? So they hit and stick. That's an inelastic collision, perfectly inelastic collision. That means kinetic energy is not conserved. That's why the question is asking how much of it is converted into thermal energy. But momentum is conserved, whether it's an elastic collision or an inelastic collision. So we use conservation of momentum to get the final speed. So the change in momentum is 0. That means P final minus P initial is 0. So P final equals P initial. Well, P final is 3 train cars, 3m, times whatever the final velocity of those 3 cars together is. That's the final momentum, the mass times the velocity. And the initial momentum is 2 train cars traveling at 2.5 meters per second plus m times 0. The third car has no momentum. So that gives me 3m Vf equals 5m, or Vf equals 5 over 3. The m's cancel. That's 1.67 meters per second. Okay. So now let's calculate how much of the initial kinetic energy is converted into thermal energy. The initial kinetic energy is 1/2 times the total mass, which is 2 m's, whatever that is. I haven't given us the mass of the train car, but we'll see we don't need it. We didn't need it for the first part because the mass is canceled. It's going to cancel out here too. Times 2, let's see, 2.5 squared. So that's equal to m times 2.5 squared, and 2.5 squared is 6.25. That's equal to 6.25 m. K final is 1/2 times the mass of the 3 cars stuck together times 1.67 squared. So that's equal to 1/2 0.5 times 3 times 1.67 squared, which is 4.18 times m. And the question asks, what fraction of the initial kinetic energy is converted to thermal energy? Well, the missing energy, right, our delta E is 0. It's Kf minus Ki plus delta E thermal equals 0. That's the conservation of energy. So Kf minus Ki is 4.18 m minus 6.25 m, which is minus 2.07 m equals minus delta E thermal. So E, the change in the thermal energy, is 2.07 m, whatever units that is. Doesn't matter because the question doesn't ask us for that number of joules. If it did, we would need to know the mass of those train cars in kilograms. It asks for the fraction of the initial kinetic energy. The initial kinetic energy is, what is it, 6.25 m. So I'm going to come over here and finish it on this one page. The fraction converted to E thermal is F equals delta E thermal divided by the initial kinetic energy. That's 2.07 m divided by 6.25 m, and the m's cancel. So F equals 0.33, or in other words, 33% of the initial KE is converted to thermal energy. Okay, now if the speeds had been different, we would get a different answer. The number of cars had been different, we get a different answer, even though momentum is conserved every time.